So in a previous video, we motivated the desire for this kind of fmap2 function that takes a two-argument function and lifts it to work over some kind of, in the context of some kind of f, whatever this f might be. And we tried to implement this with functor. We tried this in class, and maybe you tried it on your own, and it turns out that it's not possible. And I'm not going to give you a formal proof that it's not possible, but I think we had informally convinced ourselves that it's not possible. So we can use fmap. So if f is a functor, we can use fmap to map this a to b to c function over this fa, and we get an f b to c. So we get this thing here. And then we have an fb, and we want an fc. But we don't have any way to take this thing and apply it, sort of quote apply it to this to get this. Functor, the functor type class, doesn't give us enough power to be able to do that. So we have fmap takes a b to c, and gives us an fb, and gives us an fc. But what we want is something like fb to c to fb to fc. And we can't get that using functor. So, but what we can say is, well, some f's might support this. So let's make a type class for f's that can in fact support this operation. This is actually called applicative. So, well, let's see. I can't call it applicative here because it's going to conflict with the standard library. So in fact, I'll just tell you what it's called. We're not going to think in this video about implementing it, so in another video we'll do that, try implementing some examples. But for now I just want to see how it's used. So it's in fact an infix operator. It's pronounced, usually it's pronounced app, or sometimes I've heard people say splat. So this app operator, it's called app. App is short for apply. So if you squint and ignore all the f's for a moment, right, this is just b to c to b to c. So if you have a function from b to c and you have a b, then you can get a c. That's just function application. So this is kind of like function application, but in an f context, or in some kind of f world, right? So if f is maybe, this corresponds to function application when things could possibly fail. And if something fails, then sort of the rest of everything is gonna it's gonna cascade the failure, right? Or f could be list, in which case it sort of corresponds to the fact that we have a bunch of different possibilities. So we could have a bunch of different possible functions and a bunch of different possible arguments, and we could combine them in different ways to get outputs. F could be, or there's other things that we'll see. F could be a bunch of different things, and in each of those cases, function application has some particular meaning in that world. Okay, so first of all, let's see how we can implement fmap2 if I don't have a functor constraint, but in fact I have an applicative constraint. And I guess we want it to be applicative and functor, although it turns out, as we'll see, every applicative is also going to be a functor. So saying this functor part is actually kind of redundant. But we'll leave it there for now. So again, we have our G, our FA, and our FB. And well, let's get rid of that for now. So we can again use fmap to apply our function g over the fa, to map it over the fa. That's going to give us, again, an f of b to c. And we can now use this app operation, right, to say let's apply that to our fb, and that's going to give us an fc. And why is it yelling at us? Oh, because I already wrote fmap2 up here. So let's comment this one out because it doesn't work anyway. and it's still yelling at me. Oh no, I just haven't reloaded. Okay, good. This works, right? So in fact, even before we think more about how we might implement this for different f's, we could try this. So going back to our original motivation, right? We had this employee record, and we wanted to build employee records out of names and phone numbers, but in different contexts. So, maybe there's some failures involved, and we might not have a name or a phone number. Maybe we have a list. Maybe we have some kind of context. So let's try each of these. So well, I'll just go back up here. So now we know that we should be able to define this saying if in fact maybe is an instance of applicative, which it is. We could use fmap2, and I have to give it a function from name to string to employee, which I know is just going to be the employee constructor. And it's going to then give us what we want, right? This is going to be a function from maybe name to maybe string to maybe employee. And we can see what this does. If we load this, I can say maybe employee. So if I give it just name. I'm boring today. 201 555 5555. That's going to successfully build an employee record, so we get a just. But what if I had put one of these as nothing? So maybe we failed to parse the phone number, we got nothing. We're going to get nothing out, right? Or if I put either one as nothing, this one is nothing. Okay, so this kind of does what we expected this would do, right? If either one is nothing, then we just get nothing as the result. But if both are just, then we get a just. And so the applicative instance for maybe apparently already gives us that behavior for free. Let's try all employees. Notice the implementation is the same, right? The difference is, right, it has a different type, and so Haskell is picking the right instance of applicative based on what the actual type is. So in this case, it's picking the one for lists. In this case, it picked the one for maybe, right? Because fmap2 will work for any choice of f that we want. So let's try this. So all info. Let's reload first. Okay, so all employees. Alice, Bob, Carl, and then we'll do some phone numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so actually, this does something different than what we were thinking. So we were thinking about zipping them together. What you can see that what this actually did was give us every possible combination of names and phone numbers. So we get Alice with the phone 123, and Alice with the phone 456, and Alice with 79, and then Bob with 123 and Bob with 456. So this is I was hinting there the other day in class that there was another way to think about this working, and this is kind of what I was thinking of. So it turns out there is a way to make it do the zipping thing, and we'll talk about that later. For now, let's just let's see if extract employee would do the same thing. So in theory, if we have the right instance for applicative, we should be able to use the same implementation. So let's reload this, and then extract employee. Well, let's see. We need to give it I don't know. I'm not thinking of a exciting way to do this. So we'll we'll just make this be the trivial constant function that just says ignore the e and return this thing. We'll just see that we can see that it works, but not doing anything too exciting. But then this whole thing is going to give me a function from e to employee. So if I can apply it to, I'll apply it to anything that I want. I'll apply it to, true. Oh, I still ask for the type. And that works. So, great. One other thing that I will mention is that there is in the standard library a synonym for fmap is defined. So this operator, the $ inside angle brackets, is defined as a synonym for fmap. And so we could rewrite this in the following way. So instead of writing fmap gfa, I can say g, I don't even know how to pronounce this, fmap. I guess you just pronounce it fmap. Right, that's the same thing, and then this I do app fb. And in fact, these parentheses are not needed because this operator has higher precedence than this operator, so we could in fact write this as like that. And this looks really nice because it emphasizes the fact that in a sense I'm really taking this function g and applying it to fa and fb, and then I'm getting a result. But I'm doing it sort of in this f world, and so just sticking these operators in between the arguments means that I'm applying this function g, but not directly to an a and a b, but to an fa and an fb. So then I'm going to get an fc out. The next thing we might want to think about is, can we do fmap2? So if we have an applicative constraint, can we do fa to fb to fc to fd? Because of course, if we can do 2 argument functions, why can't we do 3 argument functions? And the question is applicative enough to do this, or will we have to have yet another type class to do 3 argument things? I will let you think about that. See if you can work out a way to do this with applicative, or reason that it is not possible.